Okay, one task that you will need to start working on is when you're given a fraction with radicals in the denominator, there's this thing called rationalizing the denominator. So what we need to do, the task is to find a fraction whose value is the same as the given fraction. That's key. The fraction value has to be the same, but the new fraction should have no radicals in the denominator. So let's look at this example. 6 over root 7, and let's rationalize the denominator. Now, here's an approach that people tend to try to take, and some people try to square the top and the bottom. Now, if you did square the top and the bottom, you would get rid of the radical in the denominator. The problem is, if you square the top and bottom of a fraction, that doesn't create a fraction whose value is the same. For example, if you start with 1/3 and you square it, you get 1/9. So the original fraction 1/3 and the new fraction 1/9, those are not equal in value. You type 1 over 3 in a calculator and 1 over 9 in a calculator. They are not the same number. So instead of trying to square the top and the bottom, instead of that, let's perform a valid fraction move. So we should multiply by the same thing on top and bottom. That's a different concept, right? So one idea is to try to square the top and bottom, but that's made up. That might get rid of the radical, but just not in a valid way. The valid thing to do in a fraction, one valid thing to do would be to multiply the same thing on top and bottom. So in this case, let's multiply by root 7 on top and bottom. So I hope you see that difference, that if you were to square the top and bottom, which is not a thing, it's not allowed, you'd multiply the top by a 6 and multiply the bottom by root 7. So that's not allowed. We have to multiply by the same thing on top and bottom. So we've chosen here to multiply both the top and bottom by root 7. And in the denominator, root 7 times root 7, using that same formula we've been practicing most of these slides, you get root 7 times 7. In other words, root 49. And that root 49 will simplify to just a plain old 7. So you end up with 6 root 7 all over 7. Now, there is a radical on top. Fine. You know, you started with this fraction that had a radical on bottom, and since the instructions insisted that we have no radicals in the denominator, okay, fine, but then there has to be a radical in the numerator. I mean, there's going to end up being a radical somewhere, but since the task was to not have a radical in the denominator, well, then we had to get away with having a radical in the numerator instead. There's a second way to do this. It starts the same, to multiply by root 7 on top and bottom, but the thought process of what happens next is just slightly different. So I thought I'd just present this on the same slide to see which you prefer. And in the denominator, instead of using the formula we've been practicing most of today, you can instead think of this as root 7 quantity squared. It's just what squared means. And then recall that square root and then squaring, or the second root and the second power, those undo each other and you'll get a 7. So it's just a slightly different thought process. The first step is the same. You multiply by root 7 on top and bottom. It's just a matter of, do you use the true formula about multiplying two radicals together, or do you use the other formula that the nth root and the nth power undo each other? Okay, so let's rationalize the denominator in 5 over cube root of 2. Now, if you multiply the top and bottom by cube root of 2, which seems to be the natural thing to do based on what we just looked at, you'll end up keeping radicals in the denominator. So the thing to do that will work is to multiply by cube root of 2 on top and bottom another time, a second time. Or instead of doing it in two stages, just multiply from the very beginning, from the original fraction, multiply the top and bottom by cube root of 2 times cube root of 2. So here's what that looks like. Here's the original fraction up at the top, 5 over cube root of 2, and then multiply the top by cube root of 2 times cube root of 2, multiply the bottom by cube root of 2 times cube root of 2, and then the point is, in the denominator, using our new formula, this ends up being cube root of 8. In the numerator as well, using the formula we've been practicing most of today, cube root of 2 times cube root of 2 is cube root of 4. And then in the denominator, the cube root of 8 will simplify to a 2. Here's the other approach to doing this. You can, in the denominator, think of this as cube root of 2 quantity cubed, and third root and third power undo each other, so you still end up with 2. The final answer looks the same. It's just a matter of what thought process you want to have in the middle.